Ever think about how much data we trust big tech with? Like all those companies holding our info? Well, a lot of that trust boils down to how they structure their software. It's like the architecture behind the scenes.
Absolutely.
And one of the fundamental concepts that makes all that possible is something called encapsulation in Java.
Right.
So we're going to take a deep dive into encapsulation today, try to get to the bottom of it, in about 10 minutes or so. Kind of a challenge, but I think we can do it.
I think we can, yeah.
So when we talk about encapsulation, what are we really talking about?
Well, you can think of encapsulation as the idea of bundling data and code together. Like the information your program works with variables and the code, the methods that manipulate that data, they're all racked up together in a nice little package.
Okay.
And the important part is you're controlling access to that package. So you can't just directly reach into it and mess with stuff. You have to use these well-defined interfaces.
So it's kind of like, I always think of it like a vending machine. You've got all the snacks inside, but you can't just reach in and grab one.
Right, exactly.
You got to interact with those buttons in that little slot.
Yep.
And it gives you the Snickers or whatever it is you want.
Right, and that's a great analogy because you don't need to know how the vending machine works internally to get your Snickers. You don't need to know how the money's processed or how the mechanism dispenses the snack. You just need to know how to use the interface.
Right, and that's what encapsulation does in software.
Yeah, exactly. It hides all those complex details behind this simple, controlled way of interacting with it.
So, okay, if we were to look at some Java code, and I know some of our listeners might not be programmers, but if we were to take a peek, how would this look? Can we walk through a basic example?
Sure. So let's say we have a simple program that manages student information. Without encapsulation, you might have a student class, right?
Okay.
And this class has a name and an age for each student.
Okay, so like pieces of data about the student.
Yeah, exactly.
Huh.
And if these fields are declared as public, it means any part of our program can directly access them and change them.
Okay, so no restrictions.
Right, no restrictions. And this is where things can get a little dangerous.
No, how so?
Well, let's say somebody accidentally or maybe even intentionally sets a student's age to like -100.
Which obviously doesn't make sense for an age.
Exactly. But without encapsulation, there's no mechanism to prevent that from happening.
Right, it's like leaving all the doors and windows open to our data.
Right.
Anybody can walk in and do whatever they want.
Exactly.
So how does encapsulation come in and like lock things down?
So with encapsulation, we take those fields, the name and the age, and we make them private.
Okay.
This basically puts up a wall around them. No more direct access from outside the class.
Okay, so they're hidden away.
They're hidden. And then to interact with these private fields, we define these public methods, like you were saying with the vending machine. We have getter methods to retrieve the data and setter methods to modify it.
So if I wanted to see the student's name, I would use a get name method.
Yeah, correct.
And if I wanted to change it, I'd use like a set name method.
Yes, exactly. And the beauty of this is that within those setter methods, you can put all sorts of checks and rules.
So I could say like, hey, if someone's trying to set an age to less than 0, don't let them do that.
Exactly. That's where you enforce data integrity.
Okay.
So you're not just hiding data, you're controlling how it can be accessed and modified.
And that's the essence of encapsulation, right?
Yeah, that's the heart of it.
So I can see how that would be useful for, keeping our student data accurate. But what are some of the other big advantages of encapsulation for developers? Like, why is this such a fundamental principle in software design?
Well, there are actually a lot of benefits. Security, for one. By controlling access to data, you're making it much harder for accidental corruption or malicious tampering.
That makes sense, yeah.
You also get much greater control over how data is used. You can add validation logic, like we discussed, but you can also add other behavior to those getters and setters.
Oh, interesting. Like what kind of behavior?
Let's say when you set a new name for a student, you also want to trigger an update in the user interface.
Okay.
You could put that code inside the setName method.
So it's not just about getting and setting, you can do other stuff too.
Right, you can add a lot of logic to how data is handled.
Cool.
Another big one is flexibility.
Okay.
Because you're hiding the internal workings of a class behind those public methods, you can actually change how the class works internally without breaking other parts of the code that use it.
So as long as those public methods, the getters and setters still work the same way, it doesn't matter what's going on under the hood.
Exactly. It's like upgrading the engine in your car. As long as the new engine connects to the existing transmission and everything else the same way, you don't have to redesign the whole car.
Right. That makes sense. What else?
Well, encapsulation also makes code easier to maintain.
Okay.
If all the logic for accessing and changing data is in one place, within the class itself, it's much easier to find and fix bugs.
So it's more organized.
Exactly, more organized. And it also promotes reusability.
Okay.
When your code is well encapsulated, it tends to be cleaner, more modular, and you can easily use those self-contained components in different parts of your application or even in different projects.
So it's kind of like creating these little building blocks that you can plug and play.
Exactly.
And now speaking of Java, I've often heard the term Java beans.
Right.
And I'm curious, how does encapsulation fit into the whole Java bean concept?
So Java beans are basically Java classes that follow a very specific set of conventions, and encapsulation is a core part of those conventions.
So-
A proper Java bean has all its instance variables declared as private.
Okay.
It'll have a public constructor that doesn't take any arguments. And for every private field, it'll have these corresponding public getter and setter methods, which follow a particular naming pattern.
So it's kind of like encapsulation with even stricter rules.
Exactly.
Okay.
And because Java beans follow these conventions, they're super important in a lot of Java frameworks like Spring and technologies like JSP.
Got it. So encapsulation is like the foundation that Java beans are built on.
Yeah, it's essential.
Okay, so we've talked about all the good things about encapsulation, all the benefits, but are there common mistakes that developers make, things that maybe undermine encapsulation?
Absolutely.
Like what are some of the pitfalls?
Well, one of the most common mistakes is making all the fields in a class public.
Oh, right, because it seems easier at first.
Yeah, it might seem easier, faster in the short term, but it totally defeats the purpose of encapsulation. You're basically leaving your data exposed.
Yeah, like why even bother at that point?
Right. Another common mistake is writing setter methods without any validation logic.
So you're letting anything through?
Yeah, if your setAge method doesn't check if the age is a reasonable number, then you're not really controlling anything.
It's like having a lock on your front door but leaving all the windows wide open.
Exactly.
So not very secure.
Not very secure at all. And another pitfall is exposing too much of the internal logic of a class through public methods.
Oh, okay. So you don't want to give away all the secrets.
Right. You want to hide the implementation details.
Mhm.
I'll just provide the necessary ways to interact with the object. Good encapsulation is about finding a good balance, giving enough access to be useful without revealing too much or allowing unintended manipulation.
Yeah, I get that. So you mentioned earlier that we could take encapsulation even further with this idea of immutability.
Right.
Can you explain what that means and how it works?
Sure. So immutability is a really powerful concept. It basically means creating objects that can't be changed after they're created.
Mhm.
And we do this by using the private access modifier along with the final keyword in Java.
Oh,
When you declare a field as final, it means you can only assign a value to it once, and then it's locked.
it can't be changed.
It cannot be changed.
So for instance, if we had an employee class, we could make the employee's name and their id private final.
Exactly. And then you would typically set the values of those fields in the constructor when the employee object is first created. And you would only provide getter methods for them, no setters.
So once an employee object is created, their name and ed are set in stone.
Yes, exactly.
And what are the benefits of having these immutable objects?
Well, immutability offers some significant advantages, especially in large applications or systems where you might have multiple parts of the code trying to access and change data at the same time.
Oh, I see. So it helps avoid conflicts.
Exactly. Because immutable objects can't be changed, they're inherently thread safe. You don't have to worry about coordinating access or dealing with potential race conditions. And it also makes your code more predictable and reliable because you can always be sure that the state of an immutable object will remain consistent.
So it's kind of like a guarantee that things won't change unexpectedly.
Exactly.
Okay, so we've covered a lot of ground here, the theory, some code examples, and even immutability, but I'm curious, where do we actually see encapsulation being used in the real world? Like beyond these simple examples we've discussed, where is it really making a difference?
Oh, encapsulation is everywhere in software development. I mean, it's a fundamental principle that underlies countless applications and systems.
Okay, give me some examples.
Well, think about back-end APIs.
The things that power websites and apps.
Exactly. The server-side code uses encapsulation to carefully control what data is exposed to clients and how it can be modified.
So it's like a gatekeeper for our data.
Exactly.
Okay, what else?
Another great example is online banking.
Oh.
Your account balance isn't just a number floating around somewhere. It's a piece of encapsulated data that can only be modified through very specific, carefully validated operations, like deposits and withdrawals.
So when I check my bank balance on my phone, I'm not seeing the raw data.
Nope. You're interacting with an encapsulated object that's controlling access to that data and ensuring that it's updated correctly.
That makes me feel a little bit better.
It should. Encapsulation is a big part of what makes those systems secure and reliable.
Right.
And remember we talked about Java beans?
Yeah.
Well, frameworks like Spring use encapsulation extensively to manage and configure all those software components, those beans, using their getter and setter methods. And even in mobile development, like Android, encapsulation is used to manage the lifecycle of your application screens, your activities, and the data within them.
So it's not just a Java thing, it's kind of a universal principle.
Yeah, pretty much.
Okay. So as we start to wrap things up here, what would you say is the main takeaway for our listeners about encapsulation?
I think the most important thing to remember is that encapsulation leads to cleaner, safer, and more maintainable code by controlling access to data and behavior. It's all about bundling data and the methods that operate on it into cohesive units, and then carefully managing how those units interact with the rest of your program through well-defined interfaces.
Right. So it's not just about hiding data, it's about ensuring the integrity of that data and making sure it's used in a safe and controlled way.
Exactly. It's a core principle for writing better software, and it helps you think about the boundaries between different parts of your code and how they should interact in a well-structured and predictable way.
Yeah, I'm definitely starting to appreciate the importance of that.
Good.
So as we wrap up this deep dive, I'm left with a thought. We've been talking about encapsulation in software, but this idea of controlled access, data protection, creating these secure boundaries, it seems like it could apply to so many other things, right?
Oh, absolutely.
Like how different departments in a big company interact, or even how systems in our own bodies work. It's a pretty powerful concept to consider, even outside the world of code.
Yeah, it really is.
Well, thanks for joining us for this deep dive into encapsulation. I hope it's been enlightening for our listeners.
It's been a pleasure.
And until next time, keep those digital walls strong and those data boundaries secure.
Absolutely.
We'll see you on the next deep dive.
See you then.